graphically recognize the number of solutions to a system of equations, we need to plot both of the equations on the coordinate plane. And when we do that, we'll see one of three things. All right, first, the first thing we might see is we might see an intersection. So we see the two lines, they'll intersect one another. Something similar to this, they'll intersect one another and they will have one point in common. That will be the one solution to the system of equations, right? And a similar situation would be as if you might end up with two lines that are parallel, right? So the two parallel lines, right? These two lines will never actually intersect one another, so there's no solution to that system of equations. And the final situation you'll get is you'll get one line and then you'll be drawing the next line the same way and you'll find that they both cross over each other completely. Two separate lines intersecting each other at every single point. Okay, so those are your three situations. You'll have one solution for an intersecting lines. You'll have zero solutions for two parallel lines, and you'll have infinitely many solutions for two lines that intersect each other everywhere. They're essentially the same line with two different equations. So let's take a look at what we have. Okay, so the second thing that we need to remember is we need to remember that each of these equations are written in different ways. We have this one right here. We have a slope-intercept form. So our slope m is given to us right here, and our y-intercept b is given to us as well. All right. So let's plot that to start with. All right. So we have this one here. Our y-intercept 3 is right there, so we're going to put that on 3, and our slope is 2, so that means that we are going to go up 2 and across 1. There's our slope, 2 over 1, right? And this is our line that we're given. Okay, the next step here is we've got this equation here, and if you remember, we used I, j, and k as variables, right? So we had ix plus jy equals k. And when given that, we found that negative I over j is the slope m, and we found that k over j is the y-intercept b. So let's solve that. Okay, so negative I is negative 6, because I is 6, so the inverse of that is negative 6. So we've got negative 6 over j is negative 3, so negative 6 over negative 3 is positive 2. So we've got a slope 2, and we've got a y-intercept of 9 over negative 3, or negative 3. Okay, so a y-intercept of negative 3 and a slope of 2. So if we plot these right here, we get y-intercept of negative 3 and a slope of 2, which is 2 up and 1 across. Now the first thing you'll notice, the two slopes are the same, right? And that's going to actually give us one of the first things that we're going to recognize. We're going to draw ourselves a cheat sheet right here. Is that when the two things you're going to look at is you're going to look at your slope and your y-intercept, and these are actually going to be great indicators for whether the number of solutions you have, right? So the number of solutions are going to be indicated by the slope and the y-intercept of the line. So the first thing here is that let's look at the one we've got here, is where there are no solutions. The lines don't intersect each other at any point, and what we notice is that the slopes on both lines are the same. So they're the same. All right, but the y-intercepts are different. We've got two different y-intercepts, so they're different. Right. What we will find as we go along, right, is we'll find two other situations. We'll find infinitely many solutions when the slopes are the same. They're essentially parallel lines, but if they have the same y-intercept, they're essentially the same equation, just written a different way. And the other one, the one we're most interested in, is the one solution, is when the slopes are different, right? If the slopes are different, it really doesn't matter what the y-intercept is, because if the slopes are different, you're going to get two lines that intersect one another at some point. All right. So those are the three things we're going to remember here. This one here is no solutions, because when we plotted the lines, they were parallel lines. Right? Let's take a look at a couple more examples. All right. So again, plotting this line, this one's pretty straightforward. Y-intercept of 6 and a slope of -1. That's because negative x, so it's the slope of -1. Okay. When we look at this one here, we have I, j, and k again. All right. But so we're using this one here is -5 over 5. That is our slope. So our slope is -1. We can see a pattern right here. And our y-intercept then is going to be given by 15 over 5. And 15 over 5, of course, is 3. Okay, so we can see here, again, we've got parallel lines, different y-intercepts, and a slope of that's of course -1, so the same slope, just different y-intercepts. All right, so this is another zero solution. Hopefully, as we go along, you're getting the hang of this, and we'll be able to move on from here. All right, okay, so this one here has a y-intercept of 5 over 1, so using k and j, so 5 over 1, so y-intercept of 5, and a slope of -2 over 1, so down 2 and across 1. This one here, y-intercept of 35 divided by 7 is also 5, and a slope of -14 divided by 7, which is -2 as well. You can see here, these two lines, they're essentially the same line, just given in different ways. So this system here has infinitely many solutions, because in every single point along that line, they're intersecting. So y equals 2x plus 3 gives us y-intercept of 3 and a slope of 2. This gives us a y-intercept of -3. 9 divided by -3 is -3. And a slope here of -6 divided by -3, which is 2 again. We're getting a lot of examples here which have parallel lines, so no solutions. And hopefully this last one here will give us one that intersects nicely and giving us a solution. So we've got a y-intercept of 8 from here, and a slope of -6, that's down 6 across 1, there we go, right? And the second one here is in standard form, so our y-intercept is -4 over 1, so a y-intercept of -4, and a slope of -3 over 1, so that's actually going down 3 and across 1. Let's take a look at that closer. Down 3 and across 1. And we can see here the distance between the two lines is greater up here than it is down here. So we know that at some point these two lines are going to intersect, even though we can't see it. So these two lines, this system has exactly one solution. Okay.